amino acid, it has two main groups. There's the amino group, which I can just combine it as NH2. And there's the carboxylic acid group. And then you have a hydrogen group. And the fourth one is R. And that's it. Now, this R could be anything. It could also be a carboxylic, sure. Kuch bhi ho sakta hai, as long as it's organic. Now, because this part has lone pair, तो उसकी वजह से ये basic है. Or this part, because it has the COOH group, this part is acidic. So you have a basic portion. So this part is basic. And this part is acidic. So we can say that amino acids are amphoteric. Okay. और होता क्या है कि in a neutral solution, what they'll do is that this will act as an acid and this will act as a base in a neutral solution. Okay. And what they'll do is that if you add it to a neutral solution, तो ये अपने साथ ही reaction कर जाएगा. So the carboxylic part will lose the hydrogen and make H positive. And the amine part will take that and make NH3. कैसे? By doing a dative bond या acid-base reaction. जिस तरह से भी आप देखो, it has accepted H positive. तो यहाँ पर एक positive charge आ जाएगा. And this situation is called a Zwitter ion. Okay. And this is a special case where something is acting with itself. Okay. Now this R group, it can also be acidic or basic
sir?
or even neutral. Yes.
Sir, so NH2 accepted with carboxylic H plus.
Yeah, because you have a neutral solution, there is no other source of H positive. Acha. Now let's say I take the same thing and let's see ये R किस तरह से होता है. R खुद भी acidic हो सकता है. तो ऐसा हो सकता है कि in a neutral solution ये R जो है ये भी let's suppose COOH है. Now this amino acid is complete. I think इसको aspartic acid बोलते हैं. Now this amino acid and let's say it's in neutral situation, तो ये दोनों acidic हैं. But there's only one base, which means कि इनमें से सिर्फ एक अपना H positive lose करेगा, and it could be either one of them, और यहाँ पर इससे ये NH3 बन जाएगा. Similarly, it can be basic as well. और basic के case में, for example, I think एक होता था जिसमें you had CH2OH, और यहाँ पे obviously COOH है, you have NH2, you have H. So in a situation like this, it can act as a base. So this is still going to lose it and get a negative charge, but one of these is going to accept it. So वो ammonia ही होगा most likely. So ये हमारे पास ammonia NH3 plus बना लेगा. Okay, or it can also make a dative bond with H positive अगर इसको कहीं से मिल जाए. ठीक है? अच्छा. Similarly, हमारे पास न्यूट्रल भी हो सकता है. हमारे पास कोई ऐसा भी हो सकता है कि जैसे यहाँ पे बस मिथाइल ही लगा दो. So ये भी हमारे पास एक सिचुएशन हो सकती है where it just makes a Zwitter ion by itself. अच्छा, but things might change if I put it in a medium which is itself giving us H positive or OH negative. Okay. Acha. So for example, if I have this thing and I add it to, अच्छा मैं यहाँ पे ना इसको अभी neutral ही रख रहा हूँ, CH3 है. I add it to an acidic solution. ठीक है, I have H positive here. तो अब क्या होगा कि this part is not able to lose H positive because there is already a lot of H positive available. But this part has abundance of H positive to accept. So the basic parts of the amino acid will show their colors and they will act as the base that they are. But the acidic part won't. So we get an ion which is not neutral. We get a positive ion. Over here, we were getting neutral ions. Over here, we are getting a positively charged ion. Okay. Now,
Sir,
interesting. Yeah, go on.
could you go एक बार like scroll ऊपर थोड़ा सा? Sir, इसके अंदर like the इसके अंदर दो CO वाले groups हैं.
ये वाले
Sir, उसके अंदर yeah. So like how why doesn't H plus दूसरे वाले का चला जाए? Like वो क्यों
जा
नहीं
सकता
like
है, जा सकता है, as long as there is a basic situation available. So for example, if you add a very small amount of alkali, तो ये अपना H positive lose कर देगा, and it will act. This will start to act as a buffer solution.
got it, thank you.
Yeah. So in an acidic situation, the acid part is unable to do anything. So even if ये मेरे पास acidic part होता, let's suppose यहाँ पे COOH होता, तो यहाँ पे भी COOH ही रहता, because it's not able to lose H positive because I already have a lot of those available, which means that this will be a positively charged ion now. Similarly, I can put it in a situation like NH2A and I add it to a solution that is alkaline. So now the basic part will not do anything. And the basic part will stay as it is. And the acidic part will start to react and lose H positive, जो भी वो lose कर सकता है. हाँ, अगर वो neutral है तो neutral रहेगा, but this part will still lose H positive. So this R does whatever it does based on the medium, but ये दोनों, regardless of what medium you have, one of these is going to show its colors. Okay. Now here's the thing. Let's say मैं positive charge रखता हूँ, मेरे पास एक चीज है जिसमें positive charge है, and I start adding alkali to it. तो एक टाइम आएगा कि जहां पे ये H पॉजिटिव अपने H पॉजिटिव लूज कर देगा और मुझे वापस ज्विटर आयन मिल जाएगा, ये ज्विटर आयन. सिमिलरली अगर मेरे पास एक सॉल्यूशन है जिसमें OH माइनस बहुत ज्यादा है और मेरे पास ये चीज बनी हुई है, तो मैं इसमें H पॉजिटिव ऐड करता जाता हूँ. एक टाइम आएगा जब ये वापस ज्विटर आयन में कन्वर्ट हो जाएगा बिकॉज ये H पॉजिटिव एक्सेप्ट कर लेगा. So at high pH, this is possible. At lower pH, this is possible. But I keep on adding things and I will get to a point which might not be neutral, but उसको हम बोलते हैं isoelectronic point. This is a point where you get a neutral zwitter ion. ये बात बड़ी अजीब सी लगती है कि आयन भी है और न्यूट्रल भी है, बट न्यूट्रल वो इस वजह से क्योंकि site specific charges हैं उसके पास. The amine part is positive, the carboxylic part is negative, but overall उसके ऊपर कोई charge नहीं है. So you can keep on doing this and they act as buffer solutions क्योंकि आप उनमें थोड़ी बहुत pH change करोगे ना तो they will resist the change. So that is what these amino acids do. Okay. Now these amino acids can react with each other, and that is one of the key reactions in nature. Again, this is one of the reasons we get life as it is. अच्छा, अब इसका मतलब ये है कि मुझे अमाइनो एसिड्स के बीच में अगर मैंने डिफरेंशिएट करना है कि अगर मेरे पास कार्बोक्सिलिक एसिड ग्रुप लगा हुआ है या मेरे पास OH ग्रुप लगा हुआ है, तो द अमाइनो एसिड इज गोइंग टू बिहेव डिफरेंटली एट डिफरेंट pH और उसके ऊपर चार्जेस भी डिफरेंट होंगे. मतलब अगर एल्कलाइन सोल्यूशन होगा तो वो और तरह बिहेव करेगा, एसिडिक सोल्यूशन होगा तो उसमें और बिहेव करेगा, न्यूट्रल सोल्यूशन में भी और बिहेव करेगा. तो मैं इस चार्ज को यूज करके सेपरेट कर सकता हूं these different amino acids that I have.